Now, let's switch gears and really show how ionic compounds are formed using ionic bonds and emphasize the way to write their formulas. An ionic bond is formed when a metal transfers one electron or more to a nonmetal. We talked about that at length. Always when metal reacts with nonmetal, expect ionic compound. But when a nonmetal reacts with a nonmetal, you expect covalent compound. The sum of all charges in an ionic compound must always be zero, because the number of electrons lost must be equal to number of electrons gained by the nonmetal. Who loses the electrons? The metal. Who gains the electrons? The nonmetal. Now, if you look at Na plus combining with Cl minus because opposite charges attract, making the ionic bond, to give you sodium chloride, you notice we don't show the charges in that formula. Why? If you say +1 and add -1, you get a 0. So the sum of the charges in an ionic compound must always be 0, and that's how you know you've written the formula correctly. Sodium cation has a charge of +1, chloride is -1. They meet and combine to give you a crystal lattice, which is an ionic compound because we mixed or combined metal and nonmetal, and the overall charge is going to be 0. They cancel out. Another example we can give is that of calcium and fluorine combining to give you calcium fluoride. This does not have a charge overall. The compound is neutral. We call this a compound because we defined before that compounds are made when two elements combine. Actually, two different elements combine. Calcium is in main group 2A. I expect it to react by losing 2 electrons to give you 2+. We've talked about that in the last longer lecture. Fluorine is one step to the noble gas, which would be neon. So he should be gaining 1 electron. So we would get a fluoride when fluorine gains the 1 electron. Now, let me show you something else. For you to come up with the formula of the compound CaF2 as shown here, this is the process. Your calcium has 2+. We've established that fluoride has -1. So ignore the value of those superscripts, 2+ and -1. Just go with the 2 and the 1. And drop the absolute value of 2+, which will be 2, down here. And then drop the absolute value of -1, which is 1, down here. This way, you are trying to get the formula of the ionic compound. So calcium will get the 1 down here, and your fluoride or the fluorine will get the 2. Usually in writing chemical formulas, we imply any subscript that is 1 under a symbol of an element. We ignore it. We know it's there, but we imply it. So that's how this formula is found. That said, if the formula is written as CaF2, this is really telling me that I have 1 calcium, that is from the subscript, and I have 2 fluorides, that is from the subscript. Why is that important? The calcium has a charge of 2+. Each fluoride is -1. So the calcium is bringing up +2. the two fluorides are bringing up 2 times -1. So you have +2 from the calcium cation, and you have -2 from the two fluorides. Now you tell me, if you add +2 and -2, what do you get? You get 0 overall charge. So again, ionic compounds have 0 overall charge. In summary, we can see in sodium chloride +1 and -1, they cancel out. This one combined is 0. And in lithium oxide, this one has 2 Li pluses because of the subscript 2. The oxygen has 1. Oxygen always has 2 minus because it will gain 2 electrons to get to a neon, and it's one of it. So if you are to drop the charges from lithium, you'll get +2. From oxygen, you get -2, which is these two. If you combine them, you get 0. Now in barium iodide, barium is main group 2, so he has 2+, it's a metal. Iodide is one step, iodine is one step to the noble gas in the periodic table. So he's gonna be -1. He needs to gain 1 electron to get to the noble gas. But you have 2 iodides, yet you have 1. There's a subscript 1 there. I've shown you how to do that and to get that. So barium here, the 1 barium is bringing overall charge of 2+. The 2 iodides is bringing 2 times -1, which gives you -2. You combine these, you get 0. In aluminum oxide, I see I have 2 aluminums, but I do know aluminum is in main group 3. He reacts by losing 3 electrons, so 3+. I see I have 3 oxygens, and each oxygen is 2-. Again, oxygen is 2 steps to neon. It's a nonmetal. He gains 2 electrons. The overall charge here will be 2 times +3. The overall charge for oxygen will be that's an O, it's not 30. The overall charge from the oxide will be 3 times -2. So here, this will give me +6. This will give me -6. This is how these numbers were found. And so you're going to get the overall charge here to be 0. So again, all ionic compounds tend to be neutral because the overall positive and negative charges from the cations and anions, they cancel out. They have 0 charge. We switch gear to something that I've already shown you in the last slide. How to write formulas of ionic compounds. How to write a formula for an ionic compound. That is the learning objective here. Step number 1, you want to identify which element is a cation and which is an anion. For example, in sodium chloride, I know that the cation should be the metal and the anion should be the chloride. Okay, so metals form cations, non-metals form anions, which is what I just did here. Okay, then you use the group number of a main group element to determine the charge. For example, calcium is in 2A, it's a metal. If it's a metal, he reacts by losing electrons, so it will be 2+ superscript. Oxygen right here is in main group 6A, is 2 steps to 8A. He reacts by gaining 2 electrons, so it will be 2-. Okay, chloride, for example here, chlorine is in group 7A. He's 1 step to 8A. He reacts by gaining 1 electron. We know it's a nonmetal. So you have to determine where they belong and use that to determine their charges. Here it's 2-. You could have said a 6 - A to give you -2 if you want it. And here you can say 7 - A to give you -1. Or you can work the other way around. 8 - 7 is 1. So he has to gain 1 electron, so it's -1. 8 - 6 is 2. So oxygen has to gain 2 electrons, so it's -2. Whichever way that works for you. Then step 2, you want to determine how many of each ion type is needed to neutralize the charges, so the overall charge will be 0. For example, if someone gives you calcium and they tell you that you're combining calcium with oxygen, these ones will not combine until they are in their ionic form. Now, looking at this, the charges are already cancelling. Can you see that? They're already cancelling. 2 plus and 2 minus, they are cancelling. One would have dropped, using the method I showed you, one would have dropped 2 here and 2 there, and that will give you Ca subscript 2, oxygen subscript 2. But there's a rule that elements combine in simple whole number ratios. So you just divide this through by 2, and it will end up Ca1, O1, and that, implying the ones subscripts, because we always imply those, that will be the formula. There's zero charge because, again, 2 plus negative 2 is always going to be 0. So in this case, one of each ion was needed to balance the charge. We continue. Suppose someone wanted you to write the formula of the compound called calcium chloride. So this tells me that I need a calcium and I need a chlorine. Calcium is in group 2A, is a metal, so it will be 2 plus, loses 2 electrons. Chlorine is in group 7A, it's a non-metal, one step to noble gases, so negative 1. The formula I showed you was to drop these values, absolute values of the subscript charges, drop the 2 and drop the 1. This will give me Ca1, Cl2. We imply the 1, we know it's there. It just tells me that I have 1 calcium and I have 2 chlorides. So the formula will be CaCl2, which is what you have here. Now what this is telling me is that for every 1 calcium, because the 1 is here, which is this one now, this one is this one, will react with 2 chlorines. Remember, chlorides were negative. And therefore, the calcium is bringing plus 2 overall. The chlorine is bringing twice negative 1. So you have plus 2 and you have minus 2. When you add these up, you will surely get 0. So calcium chloride has 0 overall charge. And that's the goal. And that's how you find the formula of compounds, just by exchanging those the powers, the absolute powers, power value. You find the formula is CaCl2, which is what's found here. Okay. So in this case, calcium is the metal, he gives you the cation. Oxygen is a non-metal, he gives you the anion. Calcium is the metal, gives you the cation. Chloride is the non-metal, it gives you the anion. Okay. Like I said again, you imply the ones in the subscript. So like this one, we don't need to say C1O1. No, we just say CaO. And in this one, we don't need to say Ca1Cl2. No, we just say CaCl2. You have heard me calling names like calcium chloride, calcium oxide, probably. What is the way to know how to name ionic compounds, which are compounds made from metals and nonmetals? What are the rules? What are the steps? So main group cations, that is groups 1A, 2A, 3A, they are named for the element from which they are formed. So for example, sodium, potassium, calcium, magnesium will be the first part of the name. We call it the prefix name. I'll give you an example. So if I have this formula of the table salt, the name of this will be sodium. Now the anion is a chlorine. So instead of calling it chlorine, we drop the INE, or you would say you drop the NE, but I usually say you drop the INE and add IDE, because it's the anion of the element as found in the periodic table. So this one would be sodium chloride. So this is the kind of namings that you're going to follow. So you can have potassium chloride, you can have calcium chloride, you can have magnesium chloride. Let's do this. When a metal is able to form two different cations, two naming systems are used. The first system, let's call it A, is what we call the systematic name. Follow the name of the cation by a Roman numerical in parentheses to indicate its charge. This is when the same metal can bear several charges, like ion 2, ion 3. So if I have this compound, the name of this should be ion 2 chloride. Okay, and this one, the formula, let's say you're given the formula like this, like this one. This one would be ion 3 chloride. Caution, this 3 is usually based on the charge of the ion. Remember, there's a 1 here. This 3 came from the Fe. This one came from the chloride, meaning this compound was made from Fe3 plus combining with 3Cl. This one came from here. Remember, I showed you the formula on how to generate the formulas of ionic compounds. You just drop those values to give you Fe1Cl3. So these 3 really came from the ion. So that ion in here is really ion 3 plus. Same thing here, the 2 came from the Fe. So that Fe is really Fe2 plus. And that 2 is what we emphasize here. And this 3 is what you emphasize here. You only use the Roman numericals in the systematic name if that element can have multiple charges, positive charges, if the metal has multiple positive charges. And if you go back up here, we looked at the transition metal elements, these guys, and this kind of tells you which ones to expect to use the Roman numericals. Ion itself is right here. See him? That's the ion. So you also have chromium that has 2 versions. Copper has 2 versions. You can have copper 1 chloride. This one would be copper 1 chloride, for example. But if I write it like this will be copper 2 chloride. Notice that for sodium chloride, I did not use sodium chloride. I did not have to use the Roman numericals. Why? The sodium himself only has 1 charge, Na plus. Okay. Silver has only 1 charge. Gold has 2 of them, so you have to specify mercury. Tin has 2 versions. Lead has 2 versions. You have to say lead 2 or lead 4. So that is what that slide is trying to emphasize in the systematic naming. So remember again, in the systematic name, the rule is you need to follow the name of the cation by a Roman numeral or numerical in parentheses to indicate its charge. For example, ion, the element ion can exist as ion 2 or ion 3. So we have to specify which one. We also have common name. Use the suffix OUS. Suffix is the last part of the word, of a compound word. Use the suffix "ars" for the cation with a smaller charge, and suffix "ic" for the cation with a higher charge. So you see how we have 2 versions. We have Fe with 2 plus and we have Fe with 3 plus. So if you are just going to use the common name, like the name that a common guy will use in the streets, those that cannot say ion 2, you can call it ferrous, Fe, coming from the ion symbol. While the one that has maximum charge would be ferric. So, for example, FeCl2 can be called ferrous chloride, while FeCl3 can be called ferric chloride. Those are common names, making it simpler for the common man. Here is a table showing you just how that rule is applied. Chromium can exist in 2+ or 3+ form. Systematic name will say chromium Roman 2, chromium Roman 3, but the common name will call the one with the least plus as chromas, while the one with the maximum charge 3+ chromic. So as and IC. Copper, you can have it as copper 1 or copper 2 in the systematic name, but the lesser one will be cupras. The other one will be cupric. Iron, we've talked about it. The one with +2 will be ferrous, and the one with +3 with maximum charge will be ferric. Ion 2, ion 3 corresponds to that. Mercury is interesting. Look at this one. You have 2 Hgs. So if you have 2 Hgs, yet the overall charge is positive, that tells me that 1 mercury is +1. So we'll call that mercury 1. Okay? And this one is just the only Hg with a charge of 2+. So this one will be mercury parenthesis 2. So the lesser one would be mercurous, the one with +1. The one with +2 is going to be mercuric. Tin, you have the +2 version and you have the +4 version. So you have tin 2 and tin 4. The lesser one will be stannous, and the one with maximum charge will be stannic, which is why tin symbol is not Tn. It comes from the stan, so Sn. Okay, I think that's the Latin, or is it the Greek name? So that is the idea on how to name those. Let's practice also naming anions. Those were cations with positive charges. So if you have an anion as found in the periodic table, the non-meros, you will replace the INE, especially for the halogens. You will replace the INE with IDE. So like bromine will be bromide when it gets a negative charge. Chlorine will be chloride. Fluorine will be fluoride. Iodine with that negative charge is iodide. Okay, those were the halogens, the main group 7A. Now, because the rest are not in main group 7A, they don't end with INE. Just take the root name, the prefix, first few letters. Nitrogen with 3 minus, take the nitro and then add IDE. Oxygen, take the ox, add IDE. Phosphorus, take the phosph and add ID. Remember, this is in main group 5. It's an non-meros, so it's 3 steps to the neon, noble, to the argon, noble gas. So it takes -3. Sulfur, take the sulf, drop the UR and call it sulfide. Sulfur is in main group 6A. It's 2 steps to argon. So it's going to be S2 minus to give you what we call the sulfide. So that's how you name the anions. So now let's put everything together. If you have NaF, knowing that sodium does not have any other charge, it's always Na+. Just give the name of the metal as is in the periodic table. Fluorine is a halogen, so we drop the INE and insert IDE, so the name becomes sodium fluoride. Magnesium is in main group 2. The main group 1, main group 2, main group 3 usually do not have other charges other than the charges that corresponds to their group number. So just call it magnesium. You don't need to put Roman parentheses here. Chlorine has the INE, drop INE, put IDE. So the name of MgCl2 will be magnesium chloride, not magnesium dichloride. Okay, we continue on how to name ionic compounds that contain metal and variable charge. This time we encounter copper. I showed you in the table that you can either have copper 1 or copper 2. So which version of copper do I have here? You have to follow the steps. Step 1, you have to determine the charge of the cation. And it's simple to do. Remember how I told you how to generate this formula? There's a 1 implied here. So for me, I usually do it like this. I show the 1. I tell myself this 1 came from the Cl, and this 2 on the Cl came from the copper. So I'm dealing with a metal with the charge of 2 something. It's a metal, so 2 plus. So I'm dealing with copper 2. Or if you want to call it cupric. But that is copper 2 in systematic name. And this is the process that is trying to be followed here. Since you have 2 chlorines and each chlorine is negative, that means you have overall -2. So how do you balance -2 to make sure that this guy is neutral? This is the other way to look at it. That means that we need +2. And where does it come from? It comes from the copper. So we are dealing with copper 2. This is important so that the -2 and +2 will cancel out. So the overall charge of CuCl2 is going to be 0. The whole thing is neutral. So those are 2 ways you can find which type of copper you're working with, copper 1 or copper 2. And so the name of these would be copper, parenthesis 2, and then chlorine is changed to chloride. Okay, the systematic name will go copper 2, the common name will go cupric, and the anion is just the chloride, which is why we put the name together and call it copper 2 chloride for the systematic process of naming, and then we call it cupric chloride if you're going with common naming. It depends which naming you are asked in the question. The question is always specific. Now let's do the reverse way. This time you're given a name. So the question is, how do you derive a formula from a name that is provided of an ionic compound? The way to do that, identify the metal. The metal is going to be tin. Okay, the metal is tin. The symbol for tin is SN. Remember, you can have tin 2 and you can have tin 4. And that is shown on this slide 14. You can see here, you have tin 2 and tin 4. So you really want to determine which one you're working with here. Luckily, the problem or the question tells us you're working with tin 4. So I'll write it as SN4 plus. And then the anion is going to be determined. It says oxide, so I'm working with oxygen. Now oxygen is in main group 6. Call it 6A. It's 2 steps to 8A. So he has to gain 2 electrons. That's the formula of oxygen. So now the question is, if I really want to make sure that these two, the tin 4 and the oxide, combine to give me a neutral charge, what should I do? I see that the tin itself has a charge of 4. The oxide singly brings -2. That means I have to double my oxide to give me 4 minus. So that +4 plus -4 will give me 0. Because we said the rule before, we learned the rule that ionic compounds must always be neutral. So that tells me that I have 2 oxygens in this formula. And I have 1 tin in this formula. So the formula will be SN 1 subscript 1 O2 subscript 2, implying the formula will be SnO2, and that is the formula for tin 4 oxide. That is exactly what's being done here. Okay, and we had to double the oxygens. We have to make sure we have 2 of them, which will help us to write that subscript as 2, and we only have 1 tin, so it's here, it's implied, and the formula ended up to be SnO2 for tin 4 oxide.